we can use rational inequalities to help determine when a person's fever spikes above 100.5 degrees. So let's say this function right here represents a person's temperature, X hours or T hours, after they've been infected. So I've gone ahead and entered this side of my inequality into my graphing calculator. Don't forget to include that plus 98.6. That's easy to forget about. And by the way, what that's going to do is make sure my horizontal asymptote is 98.6 degrees, the average body temperature. Then as y2, go ahead and enter in what we're trying to compare to. In this case, I want to know when is my fever above 100.5. So I entered that in as y2. Okay? I'm going to need to adjust my window because the normal 10 by 10 window definitely won't work to show me what I need to see. So what I suggest we do is for X, since that represents the time after infection, let's just go 0 to 24. That's a whole day, and that seems to make sense to me. We may not even need to go out 24 hours, but we can adjust that if we need to. Y then represents the temperature, and while we usually do Y mins of 0 in story problems, since Y actually represents a person's temperature, I know there's nobody out there that's 0 degrees, unless you're dead or something. So I think going between 95 and 105 will make a lot more sense in this problem than going all the way down to 0 degrees. So let's go ahead and graph and see if we see anything with this window. Alright, so there's the curve that represents my temperature. So I can see that it spikes initially, and then it starts to balance out at 98.6 degrees. Eventually it would get closer and closer to that. And then this red line represents where my temperature would be 100.5. And so the question was, when is my temperature greater than above 100.5? Well, visually I can see that that's this part right here. There's where the blue curve is above the line of 100.5. So I guess what we'll need to do is find these two intersection points. So to do that, remember, hit second trace and then select intersect, option 5. And you'll need to find both of these intersections. I don't know if I'll find both of them in this video just for time. So I'm going to go ahead and find this intersection point over here. Just get close to it and press enter 3 times. And I can see that that intersection occurs at 5.32 approximately. So about 5.32 hours after the infection, that's where my fever will drop back below 100.5. You know what, I guess I might as well find the other one too. So second trace, intersect, we need to find the other intersection point. So just trace over so you're closer to the other one. And again, you don't have to get right close to it, right next to it, but get as close as you can. Press enter 3 times, and the other intersection point, there's where I got the 0.47 from. So here is my solution, sort of in interval notation. The times when my fever is above 100.5 are between 0.47 hours and 5.32 hours. Notice I included parentheses because I just want to know when I was greater than, not equal to 100.5. But because this was a story problem, it probably makes more sense just to write your answer as a statement or a sentence. I would say my fever is above 100.5 between about 0.47 hours after infection and 5.32 hours.